So the next step in our derivation of the aircraft equations of motion is that we need to track the orientation of our body axis system, which is located at the aircraft centre of gravity position, remember, with respect to the Earth axis system. And we do this by defining a series of Euler angles which define these angles between these two axis systems. Now it's important that we follow the order of this sequence, of the sequence in which these Euler angles are applied to the rotation of our axis systems, because these rotations are not commutative. So what we do to do this is to define a kind of like intermediate axis system, which we call x1, y1, z1, and that's going to be parallel with the Earth axis system, x dash, y dash, z dash, but it moves as the aircraft moves, right? So we track the origin of the new axis system x1, y1, z1 as it moves with the aircraft, and we track that with reference to the Earth axis system. So the first thing we do to apply the Euler angles is to firstly rotate about the z1 axis. So we're yawing the aircraft. So remember, let's get Dusty out. So remember, the z-axis is down. So if we rotate about the z-axis, we're yawing. That's what I've tried to describe over here with this little diagram. And the yaw angle, or the heading angle, right, which is given the Greek letter psi, is positive if the aircraft nose moves to the right. And basically that transforms our axis system x1, y1, z1 into a second intermediate axis system x2, y2, z2. Then the next angle to apply in the sequence is to rotate about the y2 axis. So we're rotating about the y-axis. So remember, the y-axis is out of the right hand wing. So if we're rotating about that axis, we're pitching, right? So we rotate about the y2 axis by angle theta, and this is our pitch angle or pitch attitude. And that's positive if the aircraft nose goes up. So that transforms our second intermediate coordinate system x2, y2, z2 into our third intermediate coordinate system x3, y3, z3. And the final rotation that we have to apply is about the x3 axis. So remember, the x-axis is out the nose. So if we rotate about the x-axis, we're rolling. So we rotate about this angle phi, and that gives us our roll angle or bank angle, and that finally transforms our third intermediate coordinate system x3, y3, z3 into our body axis reference system x, y, z. So what we've done there is we've just applied these Euler angles to our Earth axis system to get to our body axis system.